Okay, now let's go back and tackle problem number 7. Problem number 7 is actually easier, except there's this little nuance to it, and I didn't want to introduce a problem with that nuance. So let's go ahead and do it. It's really not that hard. It's just one thing we have to be careful of. All right, so we have the equation set up. I've took the liberty of calculating the molarity of the initial concentration of the iodine gas. We were given in the problem 0.0456 moles in a 2.3 liter container, about yay big. And it comes out to give me a concentration molarity of 0.0198. So that's my initial, ice charts. Remember, ICE, ice charts. Why are we going to use an ice chart? Why are we going to use an ice chart? Because look what it says once again. What are the concentrations of the gases at equilibrium? So we need the concentrations of these two. There's only 2 of them. The last problem we had 4 of them. Right? There's only 2. You need those concentrations at equilibrium. You have to use an ice chart. ICE, I. The initial concentration of this. Calculated it right there. We got it. 0.0198. 0.0198. Okay. The initial concentration of the iodine ions. Those are actually the ions floating around after the I2 breaks apart, and now you got these iodines floating around. What's the initial concentration of that? Nothing. It's 0. We just started. We just put this into the flask. We just put this into the flask, and we have the concentration, but we didn't. It's not breaking down yet. We just started. So initially, at the start, I don't have any of this yet, but I will. As time goes on, this begins to get formed, and after a while we have our equilibrium. So initially, though, I have none. Okay, change. Over time, what will happen to this concentration? It'll go down. Anything on the left goes down, anything on the right goes up. Remember that. So we put negative. Okay, negative what? Well, we don't know. We'll find out. X. Get in that habit. That's why I say you can do these in your sleep pretty quick, because they're basically all the same, except for the one little trick on this one. Otherwise, most of these ice charts are done identically. Negative X, we're going to gain this, positive X. But here is the little trick. Be careful. 2. There are 2 of those made every time that breaks down. That has to go in front of the X. And that was the little tricky thing about this. It's not a big trick, but it's important to remember. Otherwise, if you don't remember that, it's screwed all up. So whenever you have a coefficient, it has to go in front of your X. Okay? And most of the problems, the vast majority of the problems we're going to do not have coefficients. So the vast majority of these, you're just going to put positive X on the right, positive X, negative X, negative X. But not this one. We have a coefficient. Put it in front of the X. All right, that was it. All right, but it does change the math a little bit later on, but we'll see. It's not hard. I like putting a line and then E. Add these 2 lines. 0.0198 minus X. 0 plus 2X is 2X. Those are the values at equilibrium. Now, we don't know what X is, so we have to figure it out and get the actual values. Let's go ahead and write our equilibrium expression. Okay, our K expression is going to be equal to. Now, I am going to write this one out because of that coefficient. Last time I didn't write it out. I didn't write these values. I just put X's directly in. And we'll get used to doing that. You just start throwing the X's right in. But I will write this one out because I have the iodine with that coefficient. Remember, if you have a coefficient, we got to square that. So be careful. That becomes squared. And then down here I have concentration of I2. All right, so let's go ahead and put the numbers in. I was given the K value for this. The K value, I didn't write it down, so where is it? K value, yum. The K for this is 3.8 times 10 to the negative 5. We'll talk about that. 3.8 times 10 to the negative 5. 3.8 times 10 to the negative 5. That's K. Is equal to, okay, I squared. Be careful here. Watch out. Be careful. Watch your math. I at equilibrium is 2X squared divided by 0.0198 minus x. Okay. All right. Now, let's do the math. Be careful here. A lot of students will make mistakes. You'll forget. That squares everything in there. Everything, everything. So 2x squared is 4x squared. 4x squared. All right. So, I'm going to erase this, get this out of the way. Here's where we stand. We're going to solve for the math. You might be all excited to go ahead and solve for x. You know, bring this up, okay, like we did last time. Bring that up, distribute through, okay. Let's go do that. Let's do, but just make sure we're on the same page here. So multiply those two. I'm going to do it over here. 3.8 times 10 to the negative 5. 0.0198. I'm going to show you something. And that equals 4. Okay? So I'm going to go ahead and do this through. Go ahead, we're going to have to distribute that. So let's do the math here. Blah, 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 blah. Oh, man. I'm running out of battery power and I'm getting tired. I'm running out of battery power literally and figuratively. Was that literally and I'm figuratively? Yeah, literally. Okay, 0.00038 multiplied by 0.0198, enter. 7.524 times 10 to the negative 7th. I just multiply those. Okay, then I'm going to multiply this by that. 3.8 times 10 to the negative 5x. Whew! Equals, I'm running into my last problem here, but I distributed that through, got that, and then I have equal to 4x. So now I'm going to get rid of this. Actually, you know what, I want to keep this over here, and I want to, I'll just kind of do that. Okay, so see it. All right. Do you see a problem? These aren't like terms. I just can't add this like I did in problem 8. In problem 8, that was just an x. It was an x squared, and I can take that x and just add it. I can't do that here because x and x squared aren't like terms. Oh, nut sauce. What does that mean? Some of you might see it. Some of you won't. And when I say it, you're going to go, oh, God. This is a term with no x. This is a value with an x. This is a value with an x squared. That's a quadratic equation. Oh, no, no, no. You said there was only one thing different, and it was that. You didn't say this is really... Calm down. Relax. Oh, I didn't know I'd get that reaction out of you. The only thing different about this problem that's going to be difficult is that you have the 2 here, that goes there, and I got to remember to square it. Well, what about the quadratic? We're not going to do it. What? We're not going to do a quadratic. What? It's a quadratic. We're not going to do it. Let me show you why. I'm going to show you something they didn't teach you in math. Your math teacher isn't going to like this one, but it works. I kept this for a reason. This is a quadratic formula. That's quadratic format. X squared, x, and a term with no x. That's quadratic. Get rid of it. You're not going to do that. Forget it. No. Let's go back to this, okay? Back when life was simple. What we're going to do is you ready for this? We are just going to get rid of that minus x. I'm just getting rid of it. You can't do that. You can't do that. Yeah, I can. Watch. Check it out. Now this math becomes easy. I'll cross multiply, divide by 4, and I'll take the square root. And we'll go through that in just a second. But some of you are still stunned that I did that. And I'm saying you can do that. Your math teacher isn't going to like it, but your math teacher would have to admit this if you pointed it out. There's something called the rule of 100. In basic chemistry, the rule of 100 means that if that x value is going to come out to be something really, really small, small and insignificant, I know it makes the x feel bad about itself, sorry. If that is so small and insignificant, it doesn't matter, we can get rid of it. And that's what's going to happen. That's going to be a small, insignificant x. It's going to be so tiny that if we get rid of it and do the math and get an answer and compare it to if we kept it, set up a quadratic, did the quadratic and got an answer, you're going to look at those two answers and go, oh man, they're the same. Exactly. So we're going to get rid of that x, y is so small. Well, how do you know it's so small? How do you know? The rule of 100. Here's what it is. What you do to determine if that x is really tiny and insignificant is you take, okay, you ready? You take the initial concentration. So I'll write that down is initial C. And you divide it by the K value. If that number comes out to be more than 100, insignificant x, get rid of it. If you do this and it comes out to be less than 100, that means that's not an insignificant x, and you'd have to keep it, and you would have to do a quadratic. You wouldn't do that to us, would you? Yeah, I do. I will go through one problem in 2 content days away. So if you were meeting, I would say 2 weeks. And we will have to do a quadratic. It's part of the CCO, course content outline, that's delivered by UNH, and we have to do what they want us to do, and that is they want you to be able to do a quadratic. But we'll go through the quadratic when the time comes. There's only one of them, and this ain't it. So for now, whew, okay, but let's see at the rule of 100, how it works. Okay, for this problem, the initial concentration was 0.0198. Divide by the K value, 3.8 times 10 to the minus 5. All right, let's see what we get. Some of you might be able to look at it already and say, that's -2, that's -5, that's a difference of like 1,000 or something like that. So it is going to be bigger than 100, but let's get a number on it. Trust but verify, 0.0198 divided by 0.000038, and we get not 1,000, but 521. Okay, 520, depends what these numbers are as well. So it comes out to be, but we can tell that it was going to be greater than 100. 521. All right, anything greater than 100, get rid of the x. It's insignificant. It won't make a difference in the answer. Now your math teacher would still want you to go through the quadratic for practice, but we ain't doing that, okay? You tell your math teacher, 9. All right, you make sure you speak that German with an attitude. Let's get this problem done now. And we'll come back to this rule of 100 many times. But we're only going to do one quadratic. Only once will the rule of 100 be less than 100, and we will have to do the quadratic, but not for a couple weeks. Okay, cross multiply, divide by 4. So let's cross multiply these two. 0.0198 times 0.000038. Enter 7.5. I did this earlier. 7.524. 7.524 times 10 to the -7. That's equal to 4x squared. All right, divide by 4. Then take the square root. Remember, get rid of that square. Take square root of both sides. All right. Oh, actually, you know what? Oh, okay. Well, it doesn't matter. We can do it that way. So then square root both sides. So then we will square root this